Now we're going to look at two-sided hypothesis tests and confidence intervals because the two are related. A confidence interval and a two-sided hypothesis test essentially produce the same result if the confidence level is the complement of the significance level, meaning that if I have the significance level, alpha, it will equal 1 minus the confidence level. So remember, the most anything could be is 1. So the complement just means that these two values added together will equal 1. Let's kind of write all this out so you can see how they're related. Here's a hypothesis test. And again, I must have a two-sided test for this to work. And you notice here I have a two-sided test. And we're saying that the center is P, it's called P naught. Okay, and I have a z-score distribution, but the center is P naught, z-score of 0. And let's just pick the confidence level as an example. So I'm going to pick a confidence level, no, not, I'm a significance level, sorry. Let's pick a significance level. Actually, I'm going to make it, should I do that? Yeah, let's create, say alpha is 5%. Significance level of 5%. So where is that here? So 5%, I mean, roughly it's about, I'm just using 68, 95, 99.7 rule to make this a little nicer, is right around -2. So the 5% that I'm talking about, what is the 5% in this picture? The 5% is this. This happens to be half of alpha, and this other one is half of alpha. So add them together, right? Alpha plus 2 plus alpha divided by 2, add them together, and that gives you alpha. So the 5% has been split onto the side, and we're doing that because we're doing a two-sided test. And that's why at the end we have to, no matter what our quote is, we have to double our p-value, or to double the area we find to get the p-value, so I can compare significance level. And let's also talk about a couple of things. So this right here is my significance level, and that means that if my p-hat value lands somewhere here, that means reject, null. Okay. So we're going to reject this fact, this null value. If it lands here, what happens? Well, we also reject null. What happens if we land here? And then between those two, then no evidence against null. And that's the pictorial view of what happens when we run a hypothesis test. Also note that the variability is an important part. For this one, this uses, as for the calculations, SDF p hat, standard deviation p hat, which is square root of p, and I'm going to just this p naught to signify that that's an actual value. P naught here divided by n. So this uses whatever value we decide is the true population proportion. Great. So now we come to the other side. And now we said that significance level and confidence level are tied by this formula. But really the reality is they're complements of each other. So in this case, I can reverse this and say, well, what is the confidence level then? Well, it should be 1 minus significance level, right? Just solving for the other variable. In this case, I'm going 0.05, which gives me a 95% confidence level. Well, again, roughly speaking, you'll notice that notice the same marks. They're at -2 and 2, roughly, and the center now is 0.95. So the difference is this is the confidence interval measures the center, while the significance level measures the outside part, but it's the same locations. So now I'm going to put right here is where the null hypothesis sits. But for the confidence interval, of course, I don't know where it is. It's some true value sitting right there. And let's talk about what happens. If I land here for a confidence interval, what happens? Well, I capture P naught. Why? Because as soon as my p-hat value lands here, I will extend using the margin of error, and it will capture this. But if I land out here, what happens? If I land out there, I will fail to capture P naught in my interval. And same thing here, same here. Fail to cap P naught. So here and here, if I have my P hat value here, when I extend, it will not capture this. If I land here, if I extend, it will not capture that, again, the null value. So really, the two things are the same. If I land here, what happens? I fail to reject the null hypothesis. Okay, no evidence. There's no evidence against the null hypothesis. But that's the equivalent of landing here on this side, and what happens here? I capture the null hypothesis. So when I capture it, the range that I create will say the following. Remember, I'm creating a range, so you'll have E hat in the center, and then this thing will extend around it. And all we're saying when we do this is true population proportion P is in this interval. That's what we're saying. So if we land here, this fails to reject the null hypothesis. This says, hey, the null hypothesis is one of these possible values. Remember, this doesn't tell you what is the true value. It just gives you a range of possibilities. All this one does says this is it or this is not. There's evidence against it or evidence against it. It's not. It just doesn't do anything else. Okay, but if it lands here, then we'll reject this notion because we have enough evidence. But if we land here, the same thing's going to happen. We're going to create an interval and it fails to capture this, which means that this is not an option. That's one of the values. So the two results will be the same. Let's look at an example and watch this work. Now, because we've done these a few times, these are all going to be two-sided tests. I'm not going to go into too much detail, and you can speed this up. And I'm not going to do too much of a talking here. So average. Okay, we have a result, and we found it to be statistically significant at the 1% level. Fantastic. Is, in your opinion, is this of practical importance? Well, I don't know. Let's see, what is this? A drug manufacturer helps on average 40% or more of the population. Now we found evidence that maybe it's not that at all. And the difference here is 0.0123. Now, it's a little more than 1%. At least that's the difference between what we thought and our statistic. So is it 1%, let's say that's really just about 38 point something. Let's say it's really that. Is that big of a difference? Well, I don't know. I don't know how the public would feel about that. I think it might be, because they say, look, it's 40% or more. So 40% would be like lowest, right? Maybe that's the way of thinking about this. This is the lowest possible value. But now it turned out that it could be even lower than that. So yeah, I'm going to say this is practical importance. Probably yes. But again, this is why this is just a personal thing. But what are the ramifications of this? But we know that this is an estimate. So let's create now a 99% confidence interval. Now, why did I choose 99%? Because if I want the two to agree, I need them to be complements. So I chose 1%. So 0.01 for significance level. That gives me 99%. All right. So now let's just create one. I'm going to just, you've created some confidence intervals, so you know how to do that. I'm going to shut up and just writing numbers for the moment. And you can try this on your own and see what you get. I'm also going to be calculating each one separately. I think it's important right now, but I'm grabbing in a lot of decimals to do, so I'm going to do that because there's going to be error. I'm going to introduce error every time I do this. If I enter exactly the numbers at the computer, it's going to come out fine. So I entered this into a calculator. And what is it? This, the standard error. So this is standard error because I'm using p-hats. When I enter this into my calculator, I get 0.004539. And this comes back again. Now, apply these together to get my margin of error. So confidence level, margin of error, critical value, margin of error, critical value, standard error. If I do that, I get the following. Now I add and subtract. And I get now that I'm 99% confident that the true proportion is somewhere between 37.6 approximately to 39.9. I mean, this is pretty close to 40%, but this could be lower. So it could be somewhere in there. So this is a practical importance. Yeah, I mean, now I'm getting, for example, before it was only 0.01, but if I go towards this other end, now it's closer to 2% difference. So yeah, this difference is practically important. I think that the manufacturer's price should not be going this low. Maybe they need to say, look, it's a 41% or, well, it turns out to be lower than that, doesn't it? So they should be going, maybe it's, 37%. That's as good as it's going to get. Now the question is, how are these two related? I mean, do they come up with exactly the same result? Well, yeah, because note, p equaling 0.4 is not part of the interval. So it's not part of it. What does that mean? That the 99% confidence level, we have rejected rejected the notion that p equals 0.4. Why? Because it's not one of the options. And that's how the two are connected. We'll do another example.